Okay, I'm going to go through this 2.4 to 2.6 inverse function review sheet in preparation for the test. And so if you have a question, you can move ahead to whichever one you wanted information about. But I'm just going to walk through them. Okay, so the first problem, I'm looking at cosine inverse or arc cosine. And so first off, do you know the formula or the derivative pattern for that? It is negative u prime, and then it's over square root 1 minus u squared. In this case, I'm looking at the 2x squared being my u. So u is equal to 2x squared. Some of you like to do this little bit of work off to the side. That would be 4x, and then u squared would be back squaring the u's, so that would be a 4x to the fourth. And now, really, it becomes just following the pattern of the derivative of arc cosine. And so I want u prime, the u prime would be a 4x over the square root of 1 minus u squared, which was 4x to the fourth. Number 2, tan inverse of 2x cubed. Well, this just identified my u. Now, do you know your pattern for tangent? Tangent, the arctan derivative would be u prime over 1 plus u squared is the pattern. So let's just set up our u would be 2x cubed, the u prime would be a 6x squared, and the u squared, which reflects back up here, would be a 4x times x cubed squared would be a 3 times 2 or 6 for that exponent. And then this work is pretty easy because it's just plug and play. So I don't want to make a negative there, you guys. That's positive. U prime is 6x squared, and then it's 1 plus our u squared, and that would be a 4x to the sixth. Problems 3 and 4 says to find the inverse derivative at a. All right, so I want the inverse. Sometimes we've seen this, referred to as g prime of a, where g is the inverse of f, and whichever way you like to look at it. So I'm really looking for g prime of 1. I'm going to use g just because it's a little easier to write. G prime of 1. Well, that gives me an ordered pair for g of 1 comma I don't know. For f, I'd have f, I need to know f prime, don't I? And I need to know f prime of some value. Well, to the function f, this 1 becomes its output number, its y value. And then I don't know for its x value. Okay, so that might be problem number 1 to solve, because I can't do a derivative on a number I don't know. So let's find the companion to this ordered pair. This is a y value, y equals 1. So I'm going to take f, the function f, and set it equal to 1. So 1 equals 5x to the fifth plus 3x plus 1. All because I'm trying to figure out what x is. Okay, let's subtract 1. Anytime I want to solve an equation, it is handiest if I have it equal to 0. Because then I can use the zero multiplication property as part of my way to solve it. So I end up with factoring out an x that was in common to this. All right, so one of the solutions here must be that x is equal to 0. This other one, if I set 5x to the fourth plus 3 equal to 0, well, the first thing I would do is subtract 3, and that's going to give me negative 3 divided by 5. Okay, when can I take something to a fourth power, which is an even power, and get a negative? That's tough to do in the real number system. So, to me, the only real solution to this problem that we generated here is x equals 0. This other is going to be imaginary numbers, imaginary roots. And we are not dealing with that in Calc 1. So our only possibility is x equals 0. Mystery is solved, isn't it? When y equals 1, remember that's how we started this whole shebang, then x is 0. So I can plop in 0 there, which then, would, if it's x equals 0 for f, then it would be 1 comma 0 to g, the reversal of the xy coordinates for the inverse function versus the original function. Hopefully we've covered that in class well enough that you are following my work there. Now, if I could find f prime at 0, then I just need to do the reciprocal, right? It's the reciprocal of f prime at 0. G prime of 1, its slope at 1, is the reciprocal of f prime at 0, which mathematically we like to write as 1 over f prime of 0. 1 over helps generate the reciprocal. Okay. Hopefully this is all squared away. So this is 1 over f prime of 0. I can evaluate f prime of 0. That should be quite easy. I'm going to get my general derivative first, and then I'll go back and get the numeric. So 25x to the 4th plus 3, taking the derivative of f. Now I want to evaluate that at 0. So I have 25 times 0 plus 3 gives us 3. F prime of 0 is 3, right? And so I end up with 1 over 3 generating a reciprocal. G prime of 1 is 1/3. Let's move to problem 4. Problem 4, what do we got? F of x equals a cubic, and we're at a equals 8. Okay, so I'm going to set up g of x is equivalent to f inverse of x. I want to know g prime of 8. G prime of 8 means that 8 is my x value. I don't know my y value. To f, I need 8 becomes its y value, right? And I don't know its x value. The way to generate that is let y equal 8. The only equation I have given to me is the f equation, so I guess I'm stuck working with that. 8 goes in for our x, or I'm sorry, for our y value, and then we get x cubed plus 4x plus 3. Solving this, don't bring the 3 over, because then I'm trying to create something that equals 5. That's going to be somewhat hard. Go the other direction. Get a 0 so we can make use of 0 properties. X cubed plus 4x minus 5. All right, a cubic function is not the easiest function to solve. We could use the rational root theorem where we look at possible rational roots, p over q, p coming from the products, the factors of 5. So things that multiply to 5 would be 1 and 5. This is always a plus minus situation. Here I've got a coefficient of 1. Q reflects on the highest degrees coefficient, and the only things that multiply to 1 are 1 and 1. So I have 4 possible rational roots. And I believe if I check this out, where's my work here? If I inserted 1 for x, it does make this a true statement. I get 1 plus 4 minus 5 does indeed equal 0. So I'm going to just tell you that x equals 1 is a rational root to this problem. You could go to your graphing calculator, key in this function, and look for, well, subtract, oh, I got a mess here. Subtract the 8 so that we can key in y equals, no, I don't want that. I do want 0 equals, I'm trying to figure out a way to explain this well to you. If you put this in your calculator, you're going to be looking for when does it equal 0. You want to look for when does it cross the x-axis, and you will find that at 1. Okay, on the test, I plan on having ones that are a little bit easier to solve. Okay, these were a little bit messy. P over Q, though, is something that you should be held responsible for, right? You should be able to do that. But in order to save a little time on the test, I probably won't put one on of that nature. All right, so we figured out that 1,8 is an ordered pair that works in our f of x function. And that means then that this would have been an 8, 1 to g. So remember, it's all about perspective. Alrighty, got that solved. Well, I need this to be 1 over f prime evaluated at 1 then. To get g prime of 8, I'm going to look at the derivative of f prime at 1. So let's do our analysis of f prime. F prime would be a 3x squared plus 4. F prime of 1 is 3 plus 4, or 7. I know its reciprocal is 1/7. G prime of 8 is 1/7. Okay, be prepared to do an inverse derivative at a point. Differentiate each of these with respect to x. I put these in there a little bit of review from earlier in chapter 2, but what you need to know is what the derivative of e to some function is. It is itself, it's e to the u times u prime. Okay, knowing that, then here's the u portion, right? 3x cubed. And I'm going to have y prime equals. It is itself, so I write down e to the 3x cubed, and then I chain off, it's a chain rule, take the derivative of this upper function, and 3 times 3 is 9x squared. And I would prefer it if you would reorganize and call this 9x squared e to the 3x cubed. Natural log. What do you know about natural log? Well, first thing you're going to have to know is how to take the derivative of any natural log of some function. That will be 1 over u, and then chain rule says take the derivative of this inside, u prime. Here is our u portion. U is really the 4x to the 5th. So y prime equals 1 over 4x to the 5th. That was the 1 over u part. Chain off, take the derivative of the inside, so I'll get 20x to the 4th. Some people will just go ahead and write this right away. They'll think u prime over u, and then this simplifies. 4 divides into 20 5 times, so I get 5. 4, take off of the 5, leaves me a 1. So I get 5 over x. 7, for each problem, use implicit differentiation. Remember, implicit differentiation is used when we don't have an explicit equation like y equals 7x. I can take its derivative so easy, dy dx equals 7, right? Super easy. But when we get to implicit equations, they are equations that have x's and y's intermixed in their equation. Now, if it were super easy, I might try to solve for y, but I see this cubic, and that's going to make things a little bit interesting. So let's just go about implicit. The derivative of a constant is 0. I'm just going to work left to right. I'll get 15x squared, and it's with respect to x, so it would be like dx dx. Well, we don't need to write that. It would reduce to 1. This will become 12 y squared. Now, since it's y is a variable that is different than x, so we have to do a little chain rule and multiply by the derivative of y with respect to x dy dx. Add with that a 3. Derivative of 3x is 3. The next thing we want to do is solve for dy dx. So I'm going to push the 3 and the 15 to the other side, and I'll subtract them, from this side, right? Giving me negative 15x squared minus 3 equals 12 y squared dy dx. Now I could keep solving. Divide by 12 y squared. Divide by 12 y squared. And this little humdinger will simplify a bit, won't it? we should be able to knock a 3 out of it. I notice 15, 3, and 12 all have a 3 in common. So I do believe I'm going to factor out a 3. You could choose to take a negative if you wanted. I'm just going to factor the 3 at this point. So I'm going to factor out a 3, which will give me negative 5 x squared minus 1 over, factor out a 3, 4 over y squared equals dy dx. Remember, those had canceled. All right. The only time I can reduce top and bottom is when I'm in a multiplication scenario. So I've got 3 times a group, 3 times a group on the bottom. 3 divided by 3 gives me 1. And then I get a final answer that looks like that. Keep that parenthesis on there. Make sense? I like those. Those are fun. Number 8, find the equation of the line normal to the function at a given point. So we see our given point. If the normal line is vertical, indicate so. Otherwise, your answer should be in slope-intercept form. Okay, so we're going to get slope-intercept form once we finish our normal line. The only way I can come into normal line is to pass through and find really the tangent slope, the tangent line slope. And I do that through a derivative, right? So I need to find f prime. All right, let's go about our business here, get our derivative. Fairly simple polynomial. So I'm getting y prime equals negative 3x squared plus 6x. So the tangent slope at x equals negative 1, and I only need x's because this derivative is only dependent on x's, will be y prime of negative 1 equals. Notice my notation, you guys. I'm letting people know what I'm doing. I'm evaluating the derivative at negative 1. Negative 3 times negative 1 squared plus 6 times negative 1. And that would be equal to negative 3 minus 6, which gives us negative 9. And I have y prime of negative 1 equals negative 1/9. That's the tangent slope. I'm not asking you about the tangent slope. I want to know about the normal line. So the normal line slope is what? Well, it's perpendicular to the tangent line. So how do I make perpendicular slopes? I use opposite. And by opposite, we're talking about the sign. Either if it was positive, I'm now negative, and vice versa. I need opposite reciprocals. The opposite reciprocal of negative 9 would be positive 1 over 9. Whoops, I'm trying to write the word normal and talk at the same time. It's not going so well. Normal slope would be positive 1/9. Opposite in sign and reciprocals. Now we get to write the equation. Write the normal equation and of normal line equation. And our point was negative 1/6, and we had this slope of 1/9. Well, anybody can do this, right? Y minus 6 equals 1/9 x plus 1. They said put it in slope-intercept form, so I will do that. I'm going to distribute my 1/9. I'm going to add a 6 so I can get y equals mx plus b format. And y equals 1/9 x. 6 could be rewritten as 54/9. So 54/9 and 1/9 make 55/9. There's our normal line. And finally, question 9. We've seen these before, but they are so important for you to understand. So part 1, I want the first one, h prime of x is what it's saying. Well, h is defined as f of x plus g of x. How do I take the derivative of two things that are added? Well, I look at each of their individual derivatives and add them together. We wanted h1 of 2. So that's going to be an f prime of 2 and a g prime of 2. That means, let's go to a table. When x is 2, I'm looking for f is 3, right? There's f of x. So this turns out to be, oh, excuse me, I just noticed the derivative. How about this? F prime of x. I'd have negative 3 halves. Almost screwed up. All right. G prime. Here's G prime. Here's 2. Where do they intersect? 3 halves. Well, that's easy to add. H prime of 2 equals 0. On to the next one. Part 2. H sub 2 of x is a fraction. We want the derivative. How do I take derivative of fractions? I use a thing called the quotient rule. F prime g minus g prime f over over g squared, bottom squared. We want to evaluate this one at 1. Alrighty. H sub 2 prime of 1 will be an f prime of 1, a g of 1, minus a g prime of 1, f of 1, all over a g of 1 squared. Okay, table work. F prime of 1 is negative 1. G of 1 is a 1. Subtraction. G prime is a 1. F of 1 is a 4. Got the top figured out. G prime of 1, G prime of 1 is a 1. Square that, still a 1. Alrighty. Move. There we go. Negative 1 minus 4 divided by 1 makes a negative 5. H sub 2 prime of 1 is negative 5. And for the last problem on this review worksheet, I'm asking you to find H sub 3, and the first thing I know is that I have a composite function. To take derivatives of a composite function, we got this handy dandy tool called the chain rule. So, H sub 3 of x, the derivative, will be derivative of the outer, leave the inside, take and multiply, chain off, which is multiplication, g prime of x. All this is happening at 2, so h sub 3 prime of 2 will be an f prime g of 2 times a g prime of 2. Here is where you have to be extremely careful. Okay, I gotta have that chart showing. People screw this up. Start on the inside of this function. G of 2. Oopsie. G of 2 is 2. So I replace G of 2 with a 2. Now I'm looking at f prime of 2. I don't put 2 down here, you guys. No. I'm doing f prime of 2 because G of 2 is 2, which is unfortunate on this problem. I wish it would have been a different number. Now we're looking for f prime of 2. So I got to go back to the chart, find f prime, find 2. Where do they intersect? Right there, negative 3 halves. And then this one will be easy. G prime of 2, 3 halves. How do I multiply fractions? Well, I go top times top, bottom times bottom, and there is our answer. Fantastic. I hope this helped you guys. Took about 25 minutes. Hopefully you skipped around where you needed help, and you keep studying. Make sure you know your inverse trig derivatives. Make sure you know your e derivative. Make sure you know your natural log derivatives. Make sure you know how to do inverse derivatives. You'll do fine. Good luck, guys.